blockchain in the context of data spaces, which is relatively a new concept to share and exchange data in the industry today. So, speaking of sharing and exchanging data, as you may already be aware, there are several benefits of actually sharing data. So I have listed a few of them here. Of course, as you know, if you have more data, it drives efficiency and productivity in the business operations, along with the optimization opportunities. And of course, if there are more data, it will also allow the development of new products and services based on this data. And another example would be it enables tailoring strategies, for example, for products, and to improve the customer satisfaction as well, to cater specifically to some specific requirements of the users. But in general, it is very beneficial for the growth of economical, social, and research activities. So how do we share in today's world? And this is kind of like a very basic approach. And here I have taken considered several organizations and a couple of countries. So as you can see, the organization A here would be sharing data with organization B. And of course, it could be with an organization in another country as well. Or maybe it could be within a government institute. But in this approach, there are several concerns that need to be addressed. The first one would be you will have to engage in more repetitive processes. For example, if organization A is sharing data with B, and then it will probably have to repeat these processes with organization C as well. And of course, how you are going to understand each other's data, or how can you technically implement or enforce the interoperability between these two different systems. And there are other implications as well. For example, how you're going to enforce access and usage policies on this data, or how you're going to search and discover data provided by other organizations. And this kind of concerns are still need to be addressed. So as a solution for this kind of concerns, there's a concept called data spaces. The key idea here is that it serves as a logical framework or a platform, which is technology agnostic, meaning it does not enforce any technological restrictions, but rather is open to a wide variety of actually technologies. But that being said, it also enables semantic and technical, legal, and organizational interoperability, which is mandatory when you are sharing data with someone else. So the key property here is that it prioritizes decentralization and data sovereignty. As you can see here in the diagram, the data of the organization A resides within the organization itself. So as I said, the data space is a logical framework. So it does not store any data, but rather allows different participants in the industry to connect with each other and to engage in contract negotiations and afterwards to share data as well. So there is an organization body to define the required concepts, the standards, or the specifications related to this domain, which is known as the International Data Space Associations, or in short, IDSA. Okay, that was an abstract view of the data space. Now let's look at a bit into technical details or low-level components of a data space. So it has actually several components. The most important component is the connector. The idea here is let's say if you're an organization willing to provide or consume data, then you will have to deploy or use at least this software component, which is known as the connector. It allows you to connect with this data space. By that means, it allows you to connect with the other participants and engage in these processes. And there are several other services in a data space that complements these data sharing processes. For example, there's a metadata broker through which you can search about the existing and available data offers and services and so on and so on. Like I mentioned before, the meaning of data is crucial as well, and that's where the vocabulary hub comes in. So it enables semantic interoperability by providing the required data ontologies or the data models, and likewise. And there's another service called Clearinghouse, which focuses on the subsequent services related to data exchange process, like clearing transactions, auditing, or even resolving conflicts that happen during an exchange process. So let's narrow down our topic into connectors here. So as you can see in the diagram, we have the connectors deployed or be used by the different companies. So the basic idea here is it's a gateway software component with multiple endpoints which are required to actually engage in the data sharing processes. But the IDS specification separates these functionalities into two different planes. The control plane is responsible for actually managing these data sharing processes. For example, if you need to start a contract negotiation, that will be happened in the control plane, whereas the data plane is only responsible for actually doing this data transfer process itself. Of course, the connector also interact with other data space components, the ones I mentioned before. And you can see a lot of different implementations of connectors today. But the one we are going to talk about in this presentation is the ADC connector, which stands for Eclipse Dataspace Components Connector. It complies with the reference architecture model defined by the IDS specification. But most importantly, it is based on this modular architecture of a connector, which means it allows you to implement custom plugins through service interfaces. The benefit of this is, like, for example, let's say if you need to have a custom clearinghouse, if you need to interact with a custom clearinghouse based on blockchain onto the connector, and the connector will be able to then interact with this external clearinghouse. What is Hyperledger? That's So as you can see in the diagram, we have the connectors deployed or be used by the different companies. So the basic idea here is it's a gateway software component with multiple endpoints, which are required to actually engage in the data sharing processes. But the IDS specification separates these functionalities into two different planes. The control plane is responsible for actually managing these data sharing processes. For example, if you need to start a contract negotiation, that will be happened in the control plane, whereas the data plane is only responsible for actually doing this data transfer process itself. Of course, the connector also interact with other data space components, the ones I mentioned before. And you can see a lot of different implementations of connectors today. But the one we are going to talk about in this presentation is the IDS Connector, which stands for Eclipse Dataspace Components Connector. It complies with the reference architecture model defined by the IDS specification, but most importantly, it is based on this modular architecture of a connector, which means it allows you to implement custom plugins through service interfaces. The benefit of this is, like, for example, let's say if you need to have a custom clearinghouse, if you need to interact with a custom clearinghouse based on blockchain, let's say, for example, you can have this plugin onto the connector, and the connector will be able to then interact with this external clearinghouse. Okay, now let's keep the data space topic aside for a while. Now let's look at Hyperledger Fabric Blockchain. What is Hyperledger Fabric Blockchain? In simple terms, it is a permission blockchain. So as you know, blockchain is a shared distributed ledger that stores data in a more persistent and an immutable way within a network, of course, maintained by multiple participants. So the key term here is the permissioned, which means you need some kind of like authentication to participate in this blockchain network. So Hyperledger Fabric is a permission blockchain. And then it allows multiple ledgers as opposed to the typical blockchain technologies we see today. And how it does is actually through a concept called channel. So within a channel, the data are stored into different storages, the usual blockchain data. And apart from that, you will also have this state database per channel. The purpose of these two storage mechanisms is from the blockchain, you will get the blockchain properties like the immutability, provenance, and from the state database, you will support efficient query mechanisms. And of course, you are also able to implement smart contracts as we see with other blockchain technologies such as Ethereum. And another important feature of this blockchain technology is that it allows you to implement client applications to interact with the ledger data. So, and again, going back to the previous example, we can also implement a dataspace clearinghouse, which stores data on a blockchain. And we can expose this service of the blockchain through a client application. Okay, now let's combine these two topics, blockchain in data spaces. So how can blockchain be used? As obvious, the main use case would be for data storage. And the perfect example would be supply chain. And it can benefit from the immutability, transparency, and provenance properties of usual blockchain. And then apart from that, we can also have access control mechanisms implemented with smart contracts. And by extending this, also we can have the authentication mechanisms based on decentralized identity, as we see often with Web3 technologies today, which uses actually verifiable credentials. This provides more control of our identities and also provides more trust as we eliminate decentralized components in this trust chain. But apart from this, can blockchain be more applicable in data spaces? So there are several non-functional requirements or functional requirements associated with data spaces. So for example, a user in data spaces should be able to pull, access, process, use, and share data, most importantly, with security and confidentiality. And for example, we can adapt the research work related to blockchain for this kind of like requirements. One example would be using homomorphic encryption on ledger data. And another example, how to value our data and compensate the users based on this data. Of course, we can see several ongoing work related to billing systems based on smart contracts, digital wallets, and distributed ledger. And of course, there are several other aspects that we can consider within this topic. And another would be to have some middleware services for data mapping and masking, and the list goes on. Okay, now let's look at the most important part of this presentation. So we looked at the use cases or the blockchain, how blockchain can be used in, or rather, what properties can we bring from blockchain into data spaces. Now let's look at how this blockchain technology can actually be integrated into data spaces. So we are going to exemplify this process with a clearinghouse of the data space. But of course, this can be generally applied to other data space services as well. So like I said before, the Dataspace connectors follow a modular architecture, including the Eclipse Dataspace Connector. So we are going to exploit this feature to implement and extend the connector implementation with an Hyperledger Fabric interface, as you can see here in the diagram. So the purpose of this interface is to allow the connector to interact with the blockchain. Okay, so let's look at a bit more technical view of this, this architecture. As you can see here, there are several components involved in this architecture. Of course, the first one would be the interface that we have in the Dataspace connector. By interface, I do not mean just the interface, but also the extension within the connector as well. It will have the corresponding functions of a clearinghouse. So the idea here is the Hyperledger Fabric interface of the connector will communicate with the client application, which is kind of like a intermediary service to this clearinghouse. The main important property of having this intermediary is that we can have middleware services. For example, we can implement authentication and authorization for all these activities of the clearinghouse in this client application. And then we have several chain codes deployed in the blockchain network. And these chain codes are more analogous to actually the services of a clearinghouse. There are actually several services of clearinghouse, for example, the logging service or the usage control claim validation service, or there could be the billing service to support different aspects of a clearinghouse. So within each of these chain code, there will be smart contracts with the exact specific implementation to support these functionalities. For example, within the login service, there will be three different services or the functions, sorry, to create a process, meaning create an instance for data exchange, and then to log messages for this specific data exchange, and also to query messages of this data exchange. And there are several other concerns that we have to consider. For example, the messages sent by the connector from here can be digitally signed to have a non-repudiation for these messages. And of course, the messages will eventually ultimately be stored in the ledger. And like I said before, the ledger has two different parts, blockchain and a state database, to support different properties of the clearinghouse. Okay, so let's look at how the processes are defined within this proposal. So I have not listed all the endpoints on all the functionalities of the clearinghouse here, but just to give a brief overview, I've included the creating a process and also querying log messages from a clearinghouse. So as you can see here, there are several components included in this process. By a process, what I mean here is actually, like I said before, the data exchange instance. It can have several information, like the contextual information, the agreement, and the owners of specific data exchange process. And this, even though we have several components here, it still follows the IDS specification of the message flows defined for the clearinghouse. And of course, these messages can either be hashed or in plain text. And if you prefer more confidentiality, then of course you can have these messages hashed. And like I said before, we can have the authentication and authorization mechanisms implemented in the client application in this approach. Okay, now let's discuss several properties of this approach. And from the perspective of clearinghouse, it is important to have immutability and provenance for the messages. And by having a ledger data in our blockchain, we kind of like satisfy these properties of the clearinghouse. And apart from that, we can also have more privacy on the stored data through separate channels, because Hyperledger Fabric allows you to have many channels between the same participants as well. And of course, there are several other properties of Fabric, the permission memberships, like I mentioned before, and there are several other properties that I have not discussed. For example, the chain code access control. You can have the access control for the chain codes. And then, of course, most importantly here is the private data collections, which are kind of provided within the blockchain layer. It enables more confidentiality by the blockchain layer itself. That means even the orderers do not get to see this data stored in the blockchain. And of course, there are the important properties that we need to look at. For example, the integrity and the non-repudiation of messages, which can be satisfied through the endorsement policies we have in Hyperledger Fabric, of course, with having digital signatures on the messages. And last but not least, we have also the sovereignty here, because we are kind of eliminating a central observer in this clearinghouse, which also means we can grant access to our messages upon explicit request. For example, if an auditor wants to audit the activities that we have done in a data exchange process, we can allow this specific auditor to view a specific set of messages. And interestingly, this allows participants to audit even the auditors. Okay, nothing good comes without a bad thing. So we have several considerations also to look at in this approach. The first one would be the infrastructure, because we are maintaining, or at least we are participating in a blockchain network here. We of course, we have to think about the setup and maintenance cost of these blockchain nodes, for example, peers, orderers, and if required, also the certificate authorities as well. And the other one would be actually participation of this network comes with the governance cost. That means we will have to at least maintain identity and membership. And of course, we have to think about enforcing policies on channels or even at the transaction level. And the other most important thing to consider here is that since we are implementing these clearinghouse services in chain code, we will also have to investigate and ensure the integrity and security of these chain codes. And the final consideration I have listed here is the transaction cost, because now within this more or less decentralized approach, each message will undergo an ordering and validation phase, which will not happen if we have a centralized architecture. Okay, finally, to conclude our presentation, I have listed several points here. In this work, we looked at how blockchain can be applied in data spaces, not just for the data storage functions, but how it can be applied beyond data plane functions into control plane functionalities as well. And then we looked at how we can achieve this and adapt blockchain in data spaces through modular architecture of a connector. Of course, we presented this with an example of Eclipse Dataspace Connector and a clearinghouse on Hyperledger Fabric. But of course, this does not mean it cannot be applied other connectors. It can generally be applied to other dataspace services and other connectors as well. And most importantly, there are several research work associated with this. And I would like to mention here the privacy concerns, because we have not fully utilized the Hyperledger Fabric properties yet in this work. But of course, any future work can utilize this and focus more on how to use specific channels and, of course, the private data collections of Hyperledger Fabric to ensure these privacy considerations of users in a data space. So this will be the end of the presentation.